Back in our kinematics unit, we learned about this word kinetic. We talked about just kinetics in general, is about the movement of objects. And we also learned about kinetic friction when we were talking about the dynamics. And just a reminder that kinetics is talking about things that are in motion or things that are moving. Okay? In motion or moving. And so I'm going to suggest that every particle that is moving, doesn't matter if it's tiny or it's big, if it's moving, as long as it has mass, it has kinetic energy. Now, we need to figure out a formula for this. So let's start by talking about work. And we learned in our last video that energy and work are very much related. So if we remember that work is the mass times, let me back up. It is the force times the distance. But then what we learned was that F, the force, is the mass times the acceleration. So our work was the mass times the acceleration times the distance. And you've seen that equation previously. So now what we need to do is we need to start thinking about things that are moving. Well, the mass really doesn't impact on the on how things are moving, and the distance is just how far it is. So let's look at this acceleration. So go back to our kinematics equations, and one of the equations that works really nicely is if we talk about the final velocity. The final velocity squared is the initial velocity squared plus 2AD. And if you forget this equation, you can go back in the videos and see if you can find it. Well, let's imagine, first of all, that our initial velocity is 0. Okay? So if the initial velocity is 0, the final velocity is just the velocity. So I'm just going to simplify this equation a little bit. Instead of saying, the VI squared here, I'm just going to put a 0. So the velocity squared is equal to, 0, but, we don't need to write the 0, plus 2 times AD. So I can rearrange this to find out what is A. And the A would be the V squared divided by 2D. And sometimes you might even write it a little bit differently. You might write it this way. You might say that A is 1/2 of V squared over D. That's saying the same thing, okay? So there is our kinematics equations that, we deal with things that are moving. Okay, so let's take that and put that into our equation here. So what I have is that the work equals the mass times V squared divided by D. I'll put the half out in front here, just makes it a little bit easier. And then we're going to multiply that by D. Okay, so here we are. This is the equation that we just imported here. It's got the 1/2. And what you should notice is that we've got this whole thing. I'm just going to clean this up a little bit here. We've got work is 1/2 mv squared d over d. Well, d over d is just anything divided by itself. It's just 1. So we have this equation that the work is 1/2 the mass times the velocity squared. But this is the work being done by a moving object. So because we're talking about a moving object, this is actually our energy. And I'm going to call it our EK for energy kinetic. It's 1/2 mv squared. Okay, I want to think about the units before we do an example. And if you want to skip ahead and just look at the examples, you can. Maybe you don't even need the examples. What I have here is and I'm just looking at units. Well, there's no units that goes with 1/2. So I've got mass, which is kilograms, multiplied by meters per second squared. And so I've got kilograms, meters squared per second squared. And that's the same thing as saying a Newton times a meter. That is the same thing as a joule. And we know that joules are the measure of work and energy. Here's the first example. So how much kinetic energy does a 4 kilogram object, so let's say we have a mass of 4 kilograms, and it's moving. It has a speed, a velocity of 5 meters per second, and it's heading east. And on my diagram, that's going to be east over there. All right, we want to know the kinetic energy. So our energy kinetic, 1/2 mv squared. It's quite simple. Let's see, mass here is 4 kilograms. The velocity, 5 meters per second squared. So let's see, this is going to be 1/2 of 4. Well, I could have done that in one step. Multiplied by 25 meters squared per second squared. Doesn't matter how I do this. I can do this without a calculator. Nice, easy example here. I got 1/2 of 100 kilograms meters squared per second squared. And so 1/2 of 100 is 50 joules. It's pretty straightforward. Here's the second example. What is the speed? Okay, I want to know the speed. I don't have a direction. I have a mass. Mass is 800 grams. Uh-oh, I don't like that. I'm going to immediately turn that into kilograms. And I have 3.6 joules. And that's my kinetic energy. Once again, I know that my kinetic energy is 1/2 m times v squared. But this time I've got my kinetic energy, so I need to do some algebra. I'm going to get rid of this half first. So I'm going to deal with that half. I'm going to say 2 times my kinetic energy is the mv squared. From there, let's move the mass. So I'm going to end up with 2 times my energy divided by the mass is my velocity squared. I don't want my velocity squared. I want my velocity. So the velocity would be the square root of 2 times the energy divided by the mass. That seems pretty straightforward. Let's see if we can get an answer. The velocity is the square root of 2 times kinetic energy is 3.6 joules divided by the mass, which was 0.8 kilograms. Now I am going to do the units here just so you can see how it works. Got to remember the joule was a kilogram meter squared per second squared. It's divided by kilograms, and then we're taking the square root of it. So if we look at that, the kilograms are going to cancel. And I was going to do my units here first. The kilograms canceled, so I have the square root of meter squared per second squared. And so the square root of the units is meters per second. Fantastic, because that's the units of speed. Okay, let's see, my velocity, it's going to be 2 times 3.6, well, that's 7.2, divided by 0.8. That's, believe it or not, I didn't make this up on purpose, but this is going to be a nice easy one. That's going to be the square root of 9. I picked random numbers and I still got a nice integer. So what is the speed? It's the square root of 9. The speed is 3 meters per second. So let's go 3.0 to keep some digits there. I could have done very similar algebra and came up with an equation to solve for the mass as well.